Okay, in the previous video we saw that when we started with parametric equations and we wanted to get a Cartesian equation, it was a good idea to try and make t the subject and then plug that into one of the equations and simplify. Okay, this is a different kind of question, alright? I actually could do this one that way because this equation is fairly convenient to rearrange to make t the subject. But when it's a show that question and we've got the Cartesian equation given, there's just a constant to find, this is really quite rare. You can treat this as verification. In other words, this, which is supposed to be our endpoint in a show that question, we can actually start by looking at bits out of this and then fit it all together at the end, and we'll actually get a value for k which will prove we've done it without cheating. Okay, so I'm going to just look at what xy squared is, because that's in the equation I'm aiming towards. Okay, so xy squared, well here's x, it's 8t squared minus t. And I'm going to multiply that by y squared, which is 3 over t squared. So 3 over t squared is 9 over t squared. I'm going to put this as a fraction. This is 8t squared minus t all over 1. So on the top I'm going to get 8t squared minus t multiplied by the top of this fraction, so that's times 9. And then on the bottom I'm going to get 1 times the bottom of this fraction squared, which is t squared. So that's my xy squared term, which I can simplify a little bit, but let's just carry on and think what else I've got. I want a 3y, so 3y is 3 lots of 3 over t, which is 9 over t. So let's try experiment. Let's look at xy squared plus 3y and see what I get. So I'm going to multiply this out. I'm going to do 9 times 8t squared. So I'm going to get 9 8s are 72. So 72t squared minus 9t all over t squared. And I'm going to add this 9 over t. Oh look, there's a common factor going on here of t. So I can divide top and bottom of the fraction by t, not by t squared. I can't cancel this t squared with this t squared, ignoring this term. I have to divide the whole of the top by something and the whole of the bottom by something. So in this particular case, I can just divide by t. So 72t squared divided by the t is 72t. Need to divide this one by t, so that's going to be minus 9. And the bottom I have to divide by t, so that's just going to be t on the bottom. So I've just done an equivalent fraction here. It's not affected the plus 9 over t. Oh, but now I can see something nice is going to happen. I can now add these two fractions. It's a show that question, so let's put in all the steps and be really convincing. So they've both got a common denominator of t, and on the top I've got 72t, I've got minus 9, and then I've got plus 9 over t, so that's plus 9, and these cancel. So I get 72t over t, which of course is just 72. So what have I done? I've started with where did this come from actually? I did up here I did xy squared, and I did 3y because those things were in the equation. And then I did x squared y, that was this bit here, plus 3y, which was this bit here. So actually that would have been a good thing to write here. xy squared plus 3y is what I'm calculating on that line. Okay, and it turns out that it equals 72. So I can now write down that the answer is, the Cartesian equation is xy squared plus 3y equals 72. So i.e. k equals 72. So notice this is a very rare kind of show that question. I do draw the conclusion, but because there's a value of k to put in, okay, it is okay to start with this endpoint, these bits here, and actually see what they work out to give. So that's worth bearing in mind.